Hello everyone. Welcome to Tagum City National High School Science Web Course on Quarter 2 Force, Motion, and Energy. Today, we will be learning about electromagnetic waves. This is the first module of Quarter 2 of Grade 10 Science. The learning competency that you should master is to compare the relative wavelengths of different forms of electromagnetic waves. Let us begin. Electromagnetic waves are transverse waves made by oscillating electric and magnetic fields. You might wonder, what is an electric field? The field surrounding an electric charge which exerts force is the electric field. This field causes the attraction of unlike charges and repulsion of like charges. Two images of electric fields are shown in this slide. One is a positively charged particle with its vector field pointing away from the particle. The other is a negatively charged particle with its vector field pointing towards the charged particle. As I have said a while ago, this electric field causes the attraction of unlike charges and repulsion of like charges. Hence the saying, like charges repel and unlike charges attract. Two positively charged particles do not attract with each other, as well as two negatively charged particles. To illustrate this phenomenon, consider this simulation from PhET website. In this simulation, we are going to add a positively charged particle. Notice the electric field around it. Now, how would this particle react if another positively charged particle is added? Notice the electric field surrounding the other positively charged particle. Let us observe. As we add another positively charged particle to the simulation, we notice that they do not attract with each other. This is because of the similar electric fields of the positive charges, which does not facilitate attraction. Let us change the charges in the simulation into negative. Notice the electric field surrounding the negatively charged particle. Now, how would this particle react if another negatively charged particle is added? Notice, again, the electric field of the other negatively charged particle. As we add another negatively charged particle to the simulation, we notice that they do not attract with each other, similar to the positively charged particles a while ago. This is because of the similar electric fields of the negative charges, which does not facilitate attraction. Now, let us remove one negatively charged particle from the simulation and replace it with a positively charged particle. Notice the electric fields of the two unlike particles. How would these two particles react? Let us observe. Because of the different electric fields of the positive and negative charges, attraction occurs. To sum up, positive to positive charge equals repel. Negative to negative charge equals repel. and positive to negative charge equals attract. This means that similar charges repel, dissimilar charges attract, such as shown in the simulation. Now let us learn magnetic fields, another vector field of an electromagnetic wave. Magnetic field describes the influence of electrical currents and magnetized materials. This field is produced by magnetic materials. This is also produced by moving charges or charges that are in motion, those that are accelerating or decelerating. When a magnetic material is sprinkled with iron filings, the influence of magnetic field becomes visible. In this slide, we see the pattern of the surrounding magnetic field. Magnetic fields and magnetism will be discussed further later in the course. The combination of electric and magnetic fields produces an electromagnetic wave, such as the illustration shown in this slide. The pink transverse wave is the electric field, while the blue transverse wave is the magnetic field. Notice that the two fields are perpendicular with each other. One complete cycle of a wave, as shown in this diagram, is the wavelength. We will learn more about the properties of electromagnetic waves later in the course. Electromagnetic waves have plenty of applications and benefits to both living and non-living things. The sunlight provides heat energy to power processes in our planets, as well as initiates the formation of vitamin D in humans. Mobile phones uses electromagnetic waves to send and receive text messages and voice calls. Wi-Fi, a wireless technology, also uses electromagnetic waves to transmit data on a wireless network. In the next video, we will be exploring the history of electromagnetic waves. See you there.